Hello everyone, today we're going to talk about element number 54, xenon. On the periodic table, xenon belongs to the noble gases. It's part of the helium, neon, argon, and krypton group. We will eventually talk about radon, which is right below xenon. So xenon is a gas that is relatively heavier than the previous noble gases. It's found in less abundance, and it's also an anesthetic, which is very expensive to use. So it's a very expensive anesthetic used in fancy vehicles as it glows blue when excited with high voltage electricity. Here we have the contrast of helium and xenon. So pure helium glows purple when electrified. In contrast, xenon glows blue when electrified. So xenon is 4.5 times heavier than air. Xenon is colorless, odorless, and tasteless. Element number 54, a balloon filled with xenon does not float but drops straight to the ground. This is because this gas is 5 times heavier than air. Xenon is mixed with air in the atmosphere, but out of every 10 million atoms in the air, only 1 is xenon. So that's the proportion. 1 out of 10 million atoms in the air is xenon. And that's why it's very expensive, because we extract the xenon from the air that we breathe, and that takes a lot of energy, a lot of time, big machinery, big equipment with a lot of electricity running through it. In order to distill the xenon from the air, it takes a lot of overall energy. So that makes it a relatively expensive process to extract. Pure xenon is valued because of the methods needed to get it in a purified form in a container. So xenon, element number 54, symbol Xe, atomic number 54, atomic weight 131.29, its color is none, standard state gas at 25 degrees Celsius, also known as 77 degrees Fahrenheit, classification non-metallic. We still haven't discussed any element that is a pure metal. We're going in a different order in this series of videos, the gases and the non-metals, and at the end of the series we'll see why. So xenon, I'm one bright fellow, I can tell you. As far as the noble gases go, I'm a bit of a tease and can actually be persuaded to make chemical compounds, so hump to the rest of those stuffed shirts. I make arc lamps so fantastically brilliant that they are used in IMAX movie projectors and the headlights of fancy automobiles. So xenon, with a density of 5.894 grams per liter, with a melting point of negative 111.7 degrees Celsius, also known as negative 169.1 degrees Fahrenheit, and a boiling point of negative 108 degrees Celsius, also known as negative 162 degrees Fahrenheit. Its discovery date was in 1898, and we will go into more detail overall. Group 0 elements are colorless, odorless gases with very low boiling points. They are also called the noble gases, or group 8. The atoms of group 0 elements have full outer shells, so they can't lose or gain electrons and are therefore unreactive. They are usually found as single atoms. So the physical properties of group 0. Group 0 elements are gases at room temperature. They are only visible when electrified with clear glass spheres. So helium, as we previously discussed, glows purple when electrified. Pure neon glows orange when electrified. Pure argon glows pale purple when electrified. Pure krypton glows blue-white when electrified. Xenon, the element that we're discussing in this video, glows blue when electrified. And radon is a transparent gas, which is also radioactive, which derives from the ground, primarily from rocks such as granite and other materials that may have radioactive minerals within the granite or the rock itself. So a key feature of noble gases is that they're unreactive. So most group 0 elements are very unreactive because their atoms cannot take any extra electrons. For example, the outer shells in argon atoms have 8 electrons and so are full. Argon, the gas that is found in the atmosphere in concentrations of 1%. Argon atoms' outer shell are full and so cannot take in more electrons. These are the properties of the noble gases. They have stable configurations. Their net energies are stable and balanced where they are, so they don't really interact to gain or lose anything in terms of net energies because they already are where all the atoms are trying to stay. So they remain. The interesting thing about xenon though is that it's one of those elements that reacts with the reactive element fluorine that we previously discussed in another video. So fluorine reacts with xenon and creates other compounds, which we will talk about later on in this video. So that was a general overview of xenon. Let's continue. So before we begin with the element xenon, we're first going to discuss the structure of the atmosphere. So together with the lithosphere, rocky crust and mantle, hydrosphere, watery parts, and biosphere, living organisms, the atmosphere is one of the 4 main components of our planet. Our knowledge about its complex composition and structure has progressed steadily since the 18th century. Since we are discussing the periodic table of elements, we have to go over every element that exists within the atmosphere, because at the end of the day, everything that exists within the atmosphere consists of elements, consists of energy. Energy creates elements, and elements create the things that we classify on the periodic table with their properties. So those varying elements in the atmosphere are nitrogen, 78%, carbon dioxide, which consists of 0.039%, methane, which is CH4, and ozone, which is O3, is a combination of oxygen combined with itself 3 times. Argon, which exists in relatively high abundance when compared to the other noble gases in the air, and oxygen, which consists of 21% of the total air that exists within the atmosphere that we use to breathe and live. So the chart here shows the relative amounts of different gases in dry air. There is also water vapor in the atmosphere. Yes, there is water in the atmosphere. Every time you take a breath, it's like you're drinking water, but you're actually inhaling it because it's in a gaseous form. It doesn't drown you because it's in a gaseous form. This means that it's high energy and it's moving at high velocities in the air, and that's why it's combined along with the other molecules in the air in the form of hydrogen and oxygen, only at greater velocity. So the water vapor in the atmosphere, which makes up 1 to 4% of air at the surface of the earth and about 0.4% of the whole atmosphere. So let's continue with xenon. Again, the reason we're talking about the atmosphere is because xenon is a noble gas that exists in the air in small concentrations, but that doesn't mean that we won't consider the rest of the atmosphere, because if we're talking about any type of gas that exists within the atmosphere, we need to talk about the whole atmosphere because it's not a single unit, it's a fusion of all of the gases and they all work together to create the atmosphere. Henry Cavendish was born into a British aristocratic family. Henry Cavendish was a shy and reclusive eccentric who only ever spoke with his scientific friends. He was the first person to determine the composition of the atmosphere and show that this composition was the same everywhere. He also discovered hydrogen, which he called inflammable air, and made an astonishingly accurate determination of Earth's density, which is pretty incredible when you think about it. A private income enabled him to devote his life to unpaid science investigation, and it is said that he made many important discoveries that he never published. So let's continue with xenon. So the element xenon, an individual known as Niels Bohr showed that it was not 100% inert by making a fluorine derivative in 1962. As previously discussed in the fluorine video, the link is in the description below, fluorine is a very reactive element. It only has 1 electron to go in its outer valence shell to be a complete stable element, and therefore it reacts with various elements on the periodic table, being that it's the most electronegative on the periodic table. So here's one of the compounds that xenon forms, called fluorosil, a drug used to treat certain types of cancer. Xenon also binds with a lot of other elements. So there are 100 xenon compounds that we made so far. There are likely more that are to be made and used for various things and properties. Xenon, again, is a noble gas that is heavy enough to react with other elements. Because of its huge mass, it's relatively unstable. If you subject it to motion, start becoming radioactive elements exclusively, because elements that are too massive are unable to exist in the time period that we exist in, because the universe exists with different conditions that they're not designed to thrive in. And it's not that the element is necessarily unstable, it's just that it's not at its temporal stability, which simply means that it's not present in a time period in the universe where it would be stable and unlikely to dissolve based on the net energy that exists in the universe around the element. So the element xenon, they realized that it was yet another member of the inert group of gaseous elements, as they were known because of their lack of chemical reactivity. So they call the new gas xenon. The word xenon comes from the Greek word which means guest, host, stranger, or friend. So by repeatedly distilling this gas, they eventually isolated a heavier gas, and when they examined this in a vacuum tube, it gave a beautiful blue glow with electrical current flowing through the element, exciting the elements and getting them to emit light of blue color. So this took place in 1898. William Ramsay and Morris Travers. William Ramsay participated in the categorization of helium, neon, argon, krypton, xenon, and radon. So those are the elements presented here. So they had already extracted neon, argon, and krypton from the liquid air. So here are the elements. Krypton is 36, neon is number 10, argon is 18. If you're interested in watching the videos for those elements, the link is in the description below. Again, a quick review of Morris Travers. Morris Travers was an English chemist who worked with Sir William Ramsay in the discovery of xenon, neon, and krypton. His work on several of the rare gases earned him the name Rare Gas Travers in scientific circles. He was a founding director of the Indian Institute of Science. So he was born in January 24, 1872, and he passed away in August 25th, 1961. His nationality was British. So in the University College of London, which operates as UCL, is a public research university located in London, United Kingdom, and a member institution of the Federal University of London. So this is xenon's birthplace. Xenon lamps are also used in ruby lasers as well as UV disinfectant lights. beds. They're also used for tanning beds. If you ever have gone to a tanning bed or a tanning booth, the lights that are presented here are a presentation of the xenon gas that is within the gas that is emitting ultraviolet light. When combined with other elements such as mercury, it can be placed in a light bulb-like container and connected to electricity to produce various types of useful light that is used for various purposes. So element number 54, xenon, is used for lighting. It's used in some car headlights, camera flashes, tanning beds, and neon lights with a blue glow, as previously discussed. It's used for spacecraft. Xenon is used for ion propulsion engines, which some satellites and spacecraft use to keep in orbit, which are very essential. Not used to travel very far or accelerate to high velocities, not yet at least, but it's at least used to maneuver through space by releasing electrons and slowly releasing mass, which allows the mass as a whole to be able to be displaced through space itself and be able to move relative to it. So continuing, xenon is used for medical imaging. Isotopes of xenon can be used in medical imaging, usually of heart, lungs, or the brain, and that's very important because before we didn't have any devices that were able to analyze the organs within the body without having to open up the body, cut it up, and see what's wrong. Luckily, we have devices that are able to scan the body without having to cut it open and perform any surgery that may damage the body or may not be necessary for the surgery in general, which saves a lot of time today because we do have those machines that run on things and gases like xenon. Xenon is used in the machines, by the way, because it's radioactive, and radioactive isotopes are changing isotopes. Changing atoms are able to be analyzed through detectors because they release different types of radiation, alpha, beta, or gamma, and those are analyzed through a detector, and that allows us to be able to see where certain types of cancers are, certain types of damage are within the body. Xenon Difluoride here is used to sketch silicon microprocessors, which is very important for things such as computers, because in computers we use the element silicon, and silicon needs to be shaped in a way that allows us to form it into useful computers. When they're refined in this way, we can use them to create very powerful computers. So again, we use xenon difluoride to sketch and manufacture these microprocessors. So here is the xenon atom, and here's the xenon gas with electricity running through it, and here's the ion propulsion system that is generated with the ions that are released thanks to the help of xenon being ionized, and this is the whole satellite. It's used to keep them in orbit. Continuing with xenon, we're just going to say that the more you learn about chemistry, if you were to become stranded on Mars like in the movie The Martian, you would be able to more easily survive because you would be able to use your chemistry skills to be able to fix yourself up with technology, tools, and chemical compounds that allow you to survive on Mars or wherever you are in the universe. So the element xenon. So just recently have scientists been able to combine xenon with elements such as oxygen, nitrogen, and carbon, which we previously discussed. The link is in the description below if you're interested. Continuing on, xenon is a noble gas, and noble gases were thought to be chemically inert until 1962, in which elements like xenon were combined with other elements on the periodic table. Here we have just a few examples: xenon difluoride, xenon tetrafluoride, xenon hexafluoride, xenon trioxide, perxenate, xenon trioxide. These are all compounds of xenon with other elements, mainly fluorine. As we can see here, the formula for xenon difluoride is XeF2. The molecular formula for xenon tetrafluoride is XeF4. The molecular formula for xenon hexafluoride is XeF6. Xenon trioxide, XeO3. Xenon oxytetrafluoride, XeOF4. Xenon tetrioxide, XeO4, and perxenate, H4, XeO6. All of these are just xenon combined with fluorine and oxygen, which is not that many elements, but it's still elements other than the noble gas itself. So xenon has the most extensive chemistry in group 18 and exhibits oxidation states of +1.5, +2, +4, +6, and +8 in the compounds it forms. So that means it can form various types of compounds with varying oxidation states, which means that it loses electrons to the other atoms that it's bound to. So continuing on, xenon being element number 54 with the average atomic weight of 131.293. This is the average atomic weight of all of the isotopes combined. The reason it's not a whole number is because often there are various different types of isotopes of the same element. Again, a quick review: an isotope is anything with the same amount of protons but with different amount of neutrons. It has to have the the same amount of protons. The electrons and the neutrons can vary, but the proton again is the soul of the element, and it determines the net property of the element. Again, isotopes can vary in mass, but they don't vary in property, and that's how we as scientists distinguish elements in the real world and in the universe. So again, quick review, this number is just the average atomic weight, average atomic mass of all of the isotopes of any element. In this case, the number 131.293 is the average of xenon, but in the case of other elements, the average atomic weight varies based on the different amount of isotopes that exist for each element, and then the varying amounts of mass that exist between those isotopes. And all of that creates that number. So let's continue. So noble gases. Since the discovery of noble gas reactivity, xenon compounds including halides, oxides, oxyfluorides, oxosalts, and numerous covalent derivatives with a number of compounds covalently bonded to a polyatomic ligand have been synthesized and structurally characterized. So xenon chemistry involves strong Lewis acid acceptors. A Lewis acid is simply an acid that accepts an electron but does not donate a proton. Here we have the definition for a Lewis acid. A Lewis acid is a chemical species that contains an empty orbital, which is capable of accepting an electron pair from a Lewis base to form a Lewis adduct. So the difference between a Lewis and a Bronsted acid and base is that a Lewis acid accepts an electron but does not relinquish its hydrogen. The same way, a Lewis base is a donor of its electron, but it does not change its form other than giving out its electron. In contrast, the Bronsted acid and the Bronsted base donate the proton and accept the proton, but they change forms, such as seen here. The hydrogen will dissociate from the chlorine and then reform. So in a Bronsted, it's the hydrogen donating the electron, but in a Lewis, it's the oxidizer donating the electron to the oxygen. So continuing on with xenon, we're going to talk about krypton because xenon compounds are poor oxidizing agents than krypton compounds because, again, if you look on the periodic table, krypton is one step above xenon. So krypton would have more net energies and would be relatively more unstable in its pre-existing bonds with other elements if it forms any, because again, it is a noble gas and noble gases rarely form bonds with other atoms on the periodic table. But if they do form bonds, the likelihood that they are more unstable increases as you decrease the number of protons or go above on the periodic table approaching neon or helium. So below are examples of xenon compounds that exist. So here we have xenon fluoride, here we have platinum fluoride, here we have a combination of xenon, fluorine, and platinum. Here we have a combination of xenon, fluorine, and platinum as well. Here we have another combination of xenon, fluorine, and platinum, just a variation of how much of each atom is in the total molecule. So xenon, platinum, and fluorine, these are the three types of elements that are presented in these compounds. We're talking about xenon. We already made a video on fluorine, and we're eventually going to make a video on platinum. So xenon is generally obtained by the separation of oxygen and nitrogen from the air. Again, as previously discussed, the air mostly consists of the element nitrogen, then oxygen, and then various other elements that form various compounds. Either that or they exist as self-oxidizing elements. If they exist in that form, then they oxidize quickly with the oxygen in the air and recombine to form either, if it's hydrogen, forming water, if it's carbon, forming carbon dioxide, and then becoming those relative gases that exist in the air that we breathe every day to survive, or just breathe as a result of existing within the air that we breathe, that we need to survive in the first place. So after this separation, generally performed by fractional distillation in a double column plant, so what happens, the liquid oxygen produced will contain small quantities of krypton and xenon. So those are the other gases that exist within the atmosphere that can be extracted from the air. The liquid oxygen will contain small quantities of krypton and xenon. So continuing on with the element xenon, finally xenon was able to be distilled thanks to this wealthy industrialist Ludwig Mond. He was an inventor that created a machine that cooled down the air well enough to be able to distill xenon to a quantity that was viable for everyday use and commercial use in general. So because of his invention, as we see here, so Ludwig was a German-born chemist and industrialist who took British nationality. He discovered an important previously unknown class of compounds called metal carbonyls. So he was born in March 7th, 1839 in Kassel, Germany. He died December 11th, 1909. His education was in Heidelberg University and Philipps University in Marburg. Just just a quick review, a little segue. So the chemistry of spiderweb. If you had a spiderweb the thickness of a pencil, it would be strong enough to stop a jet plane in midair. That's how strong the tensile strength of spiderweb is. Furthermore, spiderweb consists of things known as amino acids, which create proteins. They are found in living things, and these proteins consist of elements that I have previously made videos on. So I made videos on the elements oxygen, nitrogen, and carbon. And these elements make up spiderweb, which are made up of smaller components known as proteins, which consist of amino acids, which consist of these elements. Again, alanine, glycine, and serine. I can talk more about it in detail, but I just wanted to include that quick review and refresher on those elements. So let's continue with the element xenon, element number 54. So the unstable short-lived monohalides, xenon fluoride and xenon chloride, xenon bromide, and xenon iodide have been produced in the gas phase and are of considerable importance as light-emitting species gas lasers. Here we have xenon trioxide. The reason these are useful is because they're gases and they're combined with other relative gases that become a relative unstable gas that are able to be used for other things due to their decomposition and their varying structures and varying energies that are useful to us for various projects. So here, xenon trioxide. Xenon trioxide is an unstable compound of xenon in its +6 oxidation state. It is a very powerful oxidizing agent and liberates oxygen from water slowly, accelerated by exposure to sunlight. It is dangerously explosive upon contact with organic materials. When it detonates, it releases xenon and oxygen gas. The formula is xenon trioxide. Again, xenon, a relative noble gas, combined with O3, which is essentially ozone, an oxidizer. It oxidizes very easily. Xenon tetrafluoride is a square planar model. Xenon hexafluoride is a distorted octahedral molecule because of an extra pair of non-bonding electrons in the xenon valence shell. So here we have an image of an atom that's stable and a radioactive isotope that is unstable. Again, things that are radioactive are simply in a region of the universe that disrupt their stability and their molecular or atomic integrity that causes them to destabilize. But again, you can make anything into a relative radioactive element or isotope based on the variability of the energies that you provide it.
So that was Xenon explained in 25 minutes or less. If you're interested in watching the previous video, it was on selenium explained in 30 minutes or less. Other than that, thank you guys for watching. If you guys like this video, make sure to like, comment, subscribe. Click on the link for the previous videos if you're interested in learning about the previous elements on the periodic table, because again, all the elements work together, connect to form compounds, and create all the molecules and all the things that you see in the macro scale. So if you leave just one element behind, you may be leaving a crucial component of all of the things that make up your reality. So once again, thank you guys for having an appreciation of chemistry. Have a great day.